right, so what expression can we write to represent the total amount of flour and sugar? If you said we should put those two numbers together, boom, you're right. 2.5 plus 1 5/8. So let's take a look. Okay, so we have two people. They're solving it in two different ways. Maya converted the mixed numbers into improper fractions, and Janelle used the mixed numbers. What do Maya and Janelle need to do before solving? All right, so what strategy looks similar to the way that you solved the problem? So we have all solved the problem like this. I don't think a single one of us solved the problem like this because we haven't learned how to do this yet. All right, but basically to do this, we have to imposterize our mixed numbers. We have to turn them back into improper factor or fractions, imposterize them, make them hidden imposters again. All right, so I can show you how to do that. That is a little trick that I like to call whole times denominator plus numerator equals your imposter numerator or your improper numerator. All right. So let me take some of these words off the screen so we can work on this. Oops, there we go. Nope. Okay. So if you look at this, let's go ahead and take the first fraction. Let's take the whole. Oh, let's take the first fraction, 2.5, right? We're going to take the whole number, 2, and then we're going to multiply it times the denominator, 2, and then we're going to add the numerator, plus 1. All right, so 2 times 2 equals 4, plus 1 equals 5. So that's our new numerator, and then we keep the denominator, so 5 halves. And that's where we got that. All right, so we can try this again with whole times denominator plus numerator on this side. So there's our whole, there's our numerator, there's our denominator. So my whole, 1 times my my denominator, 8 plus my numerator, 5. So 1 times 8 is 8. 8 plus 5 is 13. And there we go. We have 13. We keep our denominator, 13/8. And that's where Maya got that fraction, 13/8. So all Maya did was make them back into improper fractions. Now, we can totally solve this problem if we we can do 5 halves plus 13/8. Same thing as before. We just have to ask ourselves the questions. Can I turn one of my denominators, or are my denominators the same? Is a 2 the same thing as 8? No. Question 2. Can I turn one of my denominators into the other one using multiplication? Can I turn a 2 into an 8 using multiplication? Yes, I absolutely can. 2 times 4 equals 8, right? So let's rewrite this fraction. 4 times 5 is 20. 4 times 2 is 8. Excuse me. And then we're going to add 13/8, which is going to give us 33/8. So 33/8, that's quite the improper fraction. So we do need to simplify this one. And this is where it starts to get to the point where doing long division is the best idea. All right. So let's just do a little bit of simplifying of 33/8. Remember, this is the same thing as 33 divided by 8. All improper fractions are division problems. All right. So 33 divided by 8. 8 goes into 3 0 times. 8 times 0 is 0. 3 minus 0 is 3. Drop the 3. 8 times 8 is 32. I'm sorry, 8 times 4. 8 times 4. 8 times 4 is 32. And that gives me a remainder of 1. All right, so there's my whole number, 4. There's my numerator, 1. And there's my denominator, 8. All right, so that is our answer by doing it with an improper fraction plus an improper fraction. So I want you to try this one on your own. 2.5 plus 1 5/8. Remember, make your kindergarten problem 2 plus 1, and make your 5th grade problem 1/2 plus 5/8, and see if it matches 4 1/8, and then come back.